Hey everyone, and welcome to our next video on the mini series on machine learning. That is, particularly, we're going to be talking about deep learning in this session. So, before we begin, I just want to make sure that everybody is able to hear me properly and see the screen as well. You guys can just put one text in the live chat so I'm able to get to know. So, let's go ahead and begin without any delay. So just to point out, in the last session, we took a look at deep learning. We're going to continue that concept of deep learning. And to paraphrase, and no pun intended, we're going to go deeper into the concepts of deep learning today. So just to remember, deep learning is a subset of machine learning, which is a subset of artificial intelligence. Deep learning particularly uses a technique where it mimics the human brain by creating its own neural network. Since it's a neural network created artificially, we call it as artificial neural network. That's basic thing we need to know. And it's also been known with a lot of research that neural networks offer better performance with small amount of data as well as larger amount of data compared to a simple machine learning algorithm. So we also got to know that in a neural network layers, there's supposed to be one input and one output layer compulsorily, and there must be at least one hidden layer. There could be more than one, but a minimum of one hidden layer should be there. And we got to know that in input layer, each element, each value or each feature, as we call, is specified as a neuron, and this neuron is transferred, each input neuron is transferred as input to every single neuron in the hidden layer. So in the hidden layer, it uses certain linear regression, linear formula like weight 1 into neuron 1 and weight 2 into neuron 2 and so on with a constant, and it will give a value either saying that the neuron is firing up or not. This is what we have learned, and based on certain neurons firing up, we get to see the output. We have also seen that the other advantages of neural networks are that they deal with unstructured input, which means you really don't have to divide the input and tell the neural network what each part of the input is. It's gonna identify it by itself. You just have to give it the input. You just have to give it the image. It will perform the entire analysis by itself. You literally do not have to. I'll repeat, you literally do not have to perform the rest of the operations by yourself whatsoever. So this is what we have got to know with neural networks till now. So let us move ahead from the concept of whatever we have learned till here over to the next part. Just before we begin with this, I just want to point out one little thing. In a neural network, think of this. I'll give you a very, very good analogy to understand this very well before we go ahead. Think of this, for example. Let's say your input is an image. Again, we're going to take image of either lion or tiger. This is what we had taken earlier. But in our next example, I'm going to take something entirely different. Now, the moment it is sent, the image, let's say the image has something like 1024 into 768 pixels. However many pixels are there, those many input features we will have, somewhere 7 lakh around. So these input features are sent over to your hidden neurons, where each neuron will identify a certain part and then figure out whether the output is either, let's say, lion or tiger. For the output to be tiger, certain neurons fire up. For the output to be lion, only certain other neurons fire up. So based on which neurons fire up, it decides. Now, here's the problem. Initially, your artificial neural network does not know what weights to provide. So the best example I can give for us to understand it very, very easily is this. Think of this. We have some input data like 2, 4, 6, 8, 10. There could be different values of input data. So based on different input data, your output may be different. For instance, let's say what we are trying to figure out is squares. Let's say we are trying to figure out squares. So given an input, it wants to figure out a square. So given an input 6, initially its weight will be random. Its weight will be random. If an input is n, what it's going to do here is perform n into, let's say something like 1 plus the default weight will also be 1. Let's say this is the equation neural network will initially have. So by this equation, its actual output is supposed to be 36. This is supposed to be the actual output. But when you calculate this, the output you will get is 1 plus 6 into 1, which is going to be 7. 7 is very far away from 36. If you calculate, the difference is huge. Since the difference is huge, the next time it comes back, the next time it updates the weight to improve its performance, what it does is, again, please note guys, first time that it tries to calculate the output will be with random weights. The random weight we have chosen is 1. We know 1 will not help. So the next time it calculates it, it realizes that this is far away. So it goes back and it tries to multiply this with something else. Like, since it's far away, it tries something like with 4. And so on. And each time it continues, it repeats, it keeps taking a different value. So each time it calculates an output, it figures out the loss. That is how far away its predicted output is from the actual output. The farther the distance from predicted output to actual output, the more it will update the weight. The smaller the distance from its predicted output to actual output, let's say predicted output is 34, the smaller the distance from predicted to actual output, the smaller it updates the weight. This it keeps repeating constantly until it reaches a close value, or until how many times you tell it to repeat. We often give a limit to repetition. Each time it goes, checks the actual output, checks the predicted output, looks at the loss, updates the weight accordingly. If the loss is very small, it will update the weight to something like 1.05. If the loss is very high, like for example it is 7, it may update the weight to something like 10. It depends on the system. It keeps updating the weight, whether increasing or decreasing, to get the right output. And each time it updates the weight and goes back to calculate output once again, that one entire roundabout stretch is called an epoch. So these are certain terms that we needed to know. So from here, what we're going to take a look at is a couple of special kinds of artificial neural networks that is called convolution neural networks. Let me just erase this. These are all not required for us now. Perfect. So we're going to take a look at something called convolution neural networks particularly, as well as something very special called RNN. I will also show you a practical example with code on how this works. Now don't worry about coding right now. I will be explaining in the coming sessions, coming mini series of the sessions, which programming language is to be used, how it affects and what to do and so on. That we have a separate episode of this mini series ahead. So let's take a look at this. Let's start with the first one, that is called convolution neural networks. As the name says, convolution. It's a neural network which has something called convolution. Convolve is to keep moving. To convolve is to keep moving constantly. So here we're going to have a convolution neural networks which is going to keep moving constantly. One of the best examples to take for this is this particular image data set. Think of this. I'll give you a simple example. Let's say you have an image. I'm going to take a very small scenario here. Let's say we have a, let's say I'm only taking a 3 cross 3. 3 cross 3 is very small. So I'm going to probably take a larger one, which is much better. I'll rather take, instead of a 3 cross 3, let's make it a 5 cross 5. Let's say we have something like this. I'll just make it larger. It'll be better for us to observe and understand. So this should be better. So take this scenario. Let's say this is the image we have. I'm just going to take 1, 2, 3. Of course, these are not straight lines, so bear with that. So let's say we have 4 lines over here. And let's say 4 rows and 4 columns. Your entire image is, let's say, something like this. Now, your artificial neural networks, as you learned before, your simple artificial neural networks, as we call as dense neural networks, they use that weight formula that we learned before. There is a constant plus weight into first neuron value plus weight into second neuron value and so on. This is what it uses. Whereas, if you take a look at a convolution neural network, what it does is, it takes the input image, let's say 5 cross 5. 5 rows, 5 columns, 5 pixels on each side. Once it takes that image, it takes something called a filter. What this filter does is, the filter goes to 3 cross 3 or 2 cross 2 depending on how you want. You can set the filter size. If I set the filter size as 2 cross 2, what it does is, it goes through the first 2 cross 2. After it goes through first 2 cross 2, again this is an image. So each value of this pixel will be somewhere between 0 to 255. 0 indicating it's completely dark, 255 indicating it's completely bright. So I'm taking an example of only a black and white image. If it's a color image, you're gonna have 3 copies of this 5 cross 5. 1 copy for red, 1 copy for green, 1 copy for blue. All of these red, green and blue go from the range of 0 to 255, where 0 indicates lowest brightness, 255 indicates highest brightness, and combination of RGB creates any color you want. So that's how a color image becomes a 3 cross multiplied by 3 matrix. I'm taking a simple example of a black and white image here, where there's only one matrix. So you're either going to have pitch black or complete white or somewhere a shade of gray in between from 0 to 255. So this is what we're looking at. So in due time, during the same time, if you have any queries or questions, feel free to ask. I would happily take your questions and answer as well. So you can decide the size of the filter. So when you take a filter of 2 cross 2, it will take the first 2 cross 2. It looks at the values here. Think of this. Let's say your image is a number 7 like this. The number 7 may go through certain, let's say, pixels. Like it may go through all these 3 pixels, and let's say these 2 pixels, and let's say this pixel, and let's say this pixel. You can say it may resemble 7. It may just. Now, since it somewhat resembles 7, how does your machine learning model identify it? Because this pixel is also yes, this is also yes, this, and this. So the way it identifies it is, a filter will go through each 2 cross 2 matrix to understand what is the brightness of each. Once a filter goes through each 2 cross 2 matrix, it will identify, okay, this is bright. So based on the lowest value being bright, it will give some value. Next, it will go to the next 2 cross 2 matrix. Depending on what are the values here, it will give some value again. So I'm just going to take something like 2, something like 5, some random values. It uses its own formula, so let's not worry about it. This 2 cross 2 is done. This 2 cross 2 is done. Let's go to the next 2 cross 2 matrix. It will figure out all the values there, and accordingly it will give you some value. Next, let's go for the next one. It will figure out all the values so there. Again, it's going to give some particular value. So since first row is done, next it's going to go to second row. Second row also it will repeat the same thing. For first 2 cross 2, next 2 cross 2, next 2 cross 2, and next 2 cross 2. So another 4 columns of values is what we need in the next row as well. Let's say something like 3, 2, 1, 9. I'll give you some random values. After this is done, let's go for the next one. Again, same step. We're gonna go through 4 values again. And then the next step, again here also we're gonna go through the same performance, 4 values again. This is exactly what we're doing. So your 5 cross 5 matrix gets turned into a 4 cross 4 matrix, which no longer identifies, which you can no longer use to show 7 on screen. Instead, it will be used to identify these patterns, whether a pattern like this exists, whether a pattern like this exists, and so on. That is what this filter will be used to identify. And like this, each filter of 2 cross 2, it will have some values like -1, 0, 1, and -1, and so on. And whatever value you get here, it gets multiplied and some formula applies and you get one value. So for each 2 cross 2 matrix, some formula is applied and you get this one value. So this 4 cross 4 matrix is obtained. So let's say I'll give something like 3, 2, 7, 8, 4, 5, 6, and 7. Now this is done for one image, for one hidden neuron. So if you have 100 hidden layer units, in your hidden layer, if there are 100 units, then each of the 100 units, that is 100 neurons, will have their own 2 cross 2 filter with their own values to identify a 4 cross 4 matrix. So each neuron will create its own 4 cross 4 matrix. When each neuron creates its own 4x4 matrix, each of these 4x4 matrix identifies certain patterns like this, or this, or this, or this, or let's say this, or this. Each neuron gets to identify certain patterns. And if this pattern exists, then the neuron will fire up. If the pattern doesn't exist, then let's say the neuron will not fire up. This is how you get to figure out which patterns exist. So if certain patterns exist, if let's say this exists and this exists, none of the other patterns exist, you can get to realize it's zero. That's how deep learning algorithms, particularly neural network, works. Neural network uses this particular thing called filter, which is there in each convolution layer. This special hidden layer that we have, which doesn't use our previous formula, like W1 into neuron 1 plus W2 into neuron 2. It doesn't use that formula. It instead uses a filter to create its own matrix, which can identify a certain feature. Now you don't have to teach it which features exist. It will identify automatically. In a machine learning algorithm, you have to teach it. In a convolution neural network algorithm, you don't. So that's the advantage. So that's exactly what happens here. You can take a convolution neural network here. For example, they're taking 5 into 5. If your input is 32 into 32, since you're taking 5x5 layers, last 4 layers cannot be selected. Think of this. If I am having 2 cross 2 layers, I can take this, 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 and this. I cannot go further on. I cannot go here because this last row, last column, I cannot take. So same way here, if you have 32 by 32 input, last 4 rows you cannot use. So since last 4 columns are you cannot use, your filtered value will be 28 by 28 given your filter is 5 by 5. Here I am taking a filter as 2 cross 2 matrix. With 2 cross 2 matrix, our 5 cross 5 input becomes a 4 cross 4 matrix. Same way in this example, a 32 cross 32 pixel input given a 5 cross 5 filter converts into a 28 cross 28 matrix. This 28 cross 28 matrix, if you feel like it is too big, because think of this, if you have 100 neurons, each neuron has a 4 cross 4 matrix. As we know, this is the output of each neuron, right? It uses a filter to get this output. If output of each neuron is 4 cross 4, which is 16 values, and you have 100 neurons, you're going to have total 16 into 100. That is 1600 features from all the neurons. That's a huge amount. If you want to reduce it so that your memory, your RAM can store it, you can continue using it, then in such a scenario, all you need to do is make sure that these particular values can be pooled together. Like 4 values can be converted into just one value. Here also 4 values can be converted into just one value. You can perform such smalling operations, which is called pooling. So pooling is a subsampling operation. That is what they are calling as subsampling. We generally call it as pooling to reduce the size. Here you can see 28 by 28 is reduced to 14 by 14. Then they're using one more convolution layer. That becomes 10 by 10. Then they're using one more feature map to reduce it further. So you can reduce it further and further to identify lesser and lesser features. That's the whole idea. I have one question. So how does the filter know which feature to use and which one to ignore? Absolutely good question. Initially, it does not know any features because based on your filter, you're going to have random values. So by your random values, it will check whether it is figuring out the output correctly or not. Depending on whether it's figuring out the output correctly or not, it will go back and update the filters so that it gets the right output. So what it does is, what deep learning algorithm does is, it keeps retrying the algorithms, retrying to figure out the output again and again by changing the filter values each time. So it's more like a trial and error method, but it knows whether it is going hotter or colder. Just like our previous session, a small game like we learned, like warmer or colder. Just like the same game, if a certain filter is used, its input can go bad. If a different filter is used, its input can go good. If its input goes better, it realizes the filter needs to move in a certain way. If its input goes bad, it realizes it needs to move in the opposite direction. So it performs a lot of these things internally. So all of these algorithms are already created. So as programmers, we don't need to worry much about that. We just need to use the right convolution layers, right functions, right methods to perform it. That's the important part from our side. So this is exactly what it does. So again, I'll show you one more example. Let's say you have an image. If you take 3 cross 3 filters, you can use multiple filters depending on how many neurons you have. If I have, let's say, 32 neurons, I need 32 different filters. If some other system has 50 neurons, it requires 50 filters. So like this, we figure out and reduce it over size. After we reduce it over size, all these values, whatever values we get in the last matrix, those values we take to figure out what will be the output. This is basically how it works. I hope the basic idea is simple. Of course, we're not going in depth and learning entire thing in practice about it. I just wanted to show you in short how exactly it works. I'll also show you one small example that we have here. So we have this already prepared data. This is called MNIST data. So I have one question. So deep learning and reinforcement can be related. You can say they are very related. Absolutely yes. Because after each output, it figures out the loss and it's trying to say what to do. Technically, in reinforcement learning, we as the users generally tell it whether it is doing right or wrong. Here, it itself decides based on looping. So let's take a look at this. Here, if you observe, we have this image. This is from MNIST digit collection. It's a 28 cross 28 pixel image, very small image. So all we are doing here is creating our own convolution neural network. I'll just show you here. This is a 28 cross 28 image. That means there are 28 rows and 28 columns of pixels. I'll show you this. You can see here row numbers and column numbers. So total 28 by 28 pixels is what you have. Now this particular data, if I send it through a 3 cross 3 filter, again don't worry about all this code for now. We can see these over time in internship or some sessions later on. But for now, I just want to show you at least one of these in practice. So when I take each one of these through a 3 cross 3 matrix, I'll just show you this in short. Let's take this simple scenario. I have this 28 cross 28 image. And I'm using a 3 cross 3 filter. If I use a 3 cross 3 filter, it will keep going like this one at a time, one at a time, one at a time. At the end, when it reaches 3 cross 3, it cannot use the last two parts. It cannot use where in the 3 cross 3 filters, 2 columns come here and 1 column is outside, or 2 columns are outside and 1 column is inside. This is not possible. So we lose 2 columns and we lose 2 rows as well. So our entire 28 by 28 matrix will become a 26 by 26 matrix when we go through a 3 cross 3 filter. You can see that here, that a 28 by 28 matrix is our input. That 28 by 28 matrix, after it goes through convolution layer, becomes a 26 by 26 matrix. This 26 by 26 matrix, since we have 32 such filters, if you calculate this, I'll just take this for instance, 26 times 26 times 32. So if you just calculate this, you get something like 21,632. That is the amount of values you're gonna have in total here. So let's move ahead from this anyway. So this is exactly what happens. So this 26 by 26 matrix are then reduced into half the size, because the amount of data, that is 21,000 nearly parameters, are too huge. Since there's such a huge amount of data, we want to reduce them so our RAM makes it easy to work with. So we take every 4 pixels and we convert it to 1 pixel. So basically we are halving the size of the matrix. When you half the size of the matrix, it becomes 13 bar 13. So that's the next step, it becomes 13 bar 13. So 13 bar 13 matrices is what we have. So if you calculate this, let's say 13 times total 32 filters, you get some value like 5,408. That is the exact amount of final values you have by which you figure out the output. So this is how convolution neural network works. You directly feed the image to the model. You're not telling it how to learn 0, how to learn 1. You're telling it nothing. You're just telling it what kind of filter to use, what kind of activation function to use, what kind of different layers to use, and so on. There's so many layers, so I'm not going to go in depth about it. I'm just giving you a small view about it. And once it is done, you then run it. So as I said, if you guys remember, I used a word called epoch, where every time it restarts with a different weight, its accuracy improves. You can see here in epoch 1, its accuracy is 77%. In epoch 2, it becomes 89, suddenly high. Because for the first epoch, it's random values. All weights are random. For the second epoch, it's going to be much better. So like that, it keeps on going ahead, it keeps on increasing. So you can get much higher values by the end. This is how you can get some really good accuracy. So when we test it, we get a good accuracy of 96.99% here, which is really good. So I'm just showing you a small introduction of what exactly is convolution neural networks. So if in interviews you are ever asked, at least for now, you'll get to know what neural networks are, what convolution neural networks are, and how exactly they work. Now, let us move ahead from convolution neural networks to something entirely different called recurrent neural networks. Recurrent neural networks is not often used for images, as it is very different from convolution neural networks. Convolution neural networks work with these pixels of data that we just learned. Recurrent neural network, on the other hand, works on text data. It always works not just on text data, any series data. Think of all the series data like Bitcoin price. Think of all the series data like COVID cases every day. Think of all the series data like air quality index each day, or even something like share price, or even something like any series data, or even text sequence as well. It works for all these purposes. I'll give you one simple example. Recurrent neural networks are good because they remember the big point, the reason why people use recurrent neural networks, the reason why even Google uses it. You may not realize, but you will never forget it from now on where Google uses it, because I'll show it to you right away. Google also uses recurrent neural networks in practice because they remember longer sequence of words. Think of this. If I give a scenario, like let's say for instance, just I'll give you a simple scenario, like Mary is in England. I'm just taking some sentences. She, let's say, bought a red dress. Now, if you ask a machine learning algorithm who bought a red dress, the machine learning algorithm will say that she bought a red dress, because it will connect red dress with the closest value of the word bought. So that is she. So machine learning algorithm will say she bought a red dress. It won't identify that Mary bought a red dress in reality. If you want it to remember longer sequence of words and calculate accordingly, you need to use recurrent neural networks. I'll give you a simple scenario. Take a look at this Google search. When I type, does Japan have the best? First thing that comes is technology, because it remembers 4 words behind. It remembers the word Japan. That's why it gives the word like technology, sushi, and everything. Or even if you give something like Japan does have the best, highest life expectancy, all these things you can easily figure out. Now, if I change from does Japan to does Switzerland, let me just change this. Switzerland have the best. You can see healthcare, chocolate, education, all these things come up. Of course, Swiss chocolates are famous, not Japanese. So it remembers 3 words behind as to what you typed here as Switzerland, and it tries to figure out accordingly. Now, Google may not work for longer sentence like Switzerland country has the best, something like that. You can still figure out something. You can still ask something, or Switzerland in the world has the best, something you can figure out and ask. You can see some things are here. Similarly, you can again change to Japan, for instance. So unless Google remembers these previous words, Google is not able to answer them. Like here, does USA have the best, whatever it is, education system, buy, sales, or let's say, does any other country. Take something, for instance, Mexico have the best food, boxes, chocolate, candy, anything. So it remembers words far away. The reason it remembers words far away is because Google uses recurrent neural networks. With recurrent neural networks, it remembers words far away and predicts the next word. This is a real world example of recurrent neural networks. Even things like stock market prediction. You need to predict stock based on last 100 days of data. Think of something. Some stocks go better in summer and go worse in winter. So if it only remembers this much, the model will go straight up. But model has to remember all the previous things to say no, it's going to go down, right? So all of these are real world examples where recurrent neural networks are used. So this is where we see all these things in real world. Another, as I pointed out, a very simple example. How do I fill in a? You get to see that using Google text predictive text. Even in your phone, you have these predictive texts with Google using the same thing. But most of the times when you want to use deep learning algorithms, you need good graphical processing units, because the amount of data is huge. Since the amount of data is huge, there's a lot of GPUs, graphical processing units, that can help perform this quicker, that can help you calculate very quickly for any of these things. So that's one thing that we just need to know. So anyway, moving ahead with this, I hope the basic idea, not a complicated thing, not too much, but I hope at least the basic idea of how these machine learning algorithms work, particularly deep learning algorithms work, is very clear to everyone. So if you'd like to know more, if you'd like to have a complete practical exposure from Python in scratch, literally from scratch, that we're going to teach you, you're going to learn from scratch of Python until how to build your very complicated deep learning algorithm to perform stock prediction and so on. We have an internship course that's going to begin from 2nd of December. If you're interested in joining it, if you want to know more about it, if you want to have any queries you want to ask, go through the information in our channel. You will definitely be able to get information. The same info will also be posted in the comments and chat section of this video very soon as well. You guys can check this for any registration or queries. With this, I hope you have a fun idea. I hope you have a very nice idea of what exactly is deep neural networks, deep learning. With this, in our next session, which is tomorrow, in our next episode of this mini series, we're going to take a look at the future of machine learning, which is called transfer learning. This is so huge. Not a lot of people know this, but it's literally going to be the present and the future of research in machine learning. So tomorrow we're going to have a bird's eye view. We're going to have a look at that as well. So until we catch up, keep practicing, keep working hard for